Thank you, Alex, and it's my honor to chair a gray-haired panel on speech. So I was counting the median age is roughly equal to Alex's age. So it is good. But before we do the panel itself, Joseph Mariani is going to give a short introduction on the dark ages that were still in black and white.
So I will introduce this session by speaking about the prehistory of speech and dialogue at my lab, LIMSI, CNRS in the 70s, with tiny links with oceans, aviation, and space. Okay, so this doesn't work. It was planned not to work. So we will use human-to-human command. I will say next, and the human will do the next. Hopefully. Okay, so 1973 is the year when I graduated from the Aeronautics and Space Engineering School, and when I joined LIMSI, so the CNRS Computer Science Laboratory for Mechanics and Engineering Sciences. So the head of the space group at that time was Jean-Sylvain Liénard. He was also the supervisor of my thesis, and the director was Lucien Malavard. So actually he was graduated from the same school as me. And Lucien Malavard was a specialist in fluid dynamics with applications to aeronautics, of course, but also to the TGV train and to the Halcyon boat. Oops, it works. Yeah, so the Halcyon he designed for Commandant Cousteau. And this is based on the turbo sail. So it's based on the Magnus effect. And you see here the Halcyon, also called the windmill, in Antarctica in front of penguins. You see here also the Halcyon, so arriving in Manhattan Harbor. So Commandant Cousteau is in the center, and Lucien Malavard is on the left. But as I said, there was also a connection with aerospace. And this is Lucien Malavard together with Neil Armstrong in Presidential Air Force 2. This was in September 1970. So this is for the links with oceans, aviation, and space. So when I arrived at LIMSI, there was already Icophone speech synthesizer. So it was like 1 cubic meter full of electronics. You see it here, and there is a loudspeaker on the top, and there are 44 oscillators from 100 Hertz to 4,400 Hertz. And only one copy of this synthesizer was sold, actually to the Minister of Education of the Shah in Iran for playing in his office. Only one copy. But there was also a speech analyzer for speech analysis and then recognition and understanding. And it's also about 1/2 cubic meter full of electronics. There is also a loudspeaker on the top, but also with a microphone input. And my very first task when I arrived at LIMSI was to optimize the bandpass filters. So optimizing the central frequency, the bandwidth, and the gain with all those 128 buttons. This was the first task I had to achieve. Okay, and also we had one of the very first computer which was used in the research laboratory in France. It was the IBM 1130. So it has a punch tape reader, then a punch card reader, a printer, and the central unit has 65 kilobytes of memory with a disk drive with 1 megabyte disk, which is hardly enough to store one single image nowadays. So with this, I was asked in my engineering thesis to develop a pilot plane spoken dialogue system for the Rafale jet fighter, which was under preparation at that time at Dassault. So I asked, where is the data, of course? And the answer was, there is no data. There is no data because it's classified secret defense. So what they say, they gave me a helmet, oxygen mask, and oxygen bottle. This is me with this in the computer room. And I had to use it to make the recordings. So this is me conducting those recordings in the computer room at the time. But of course, it was not enough. It was not enough because there was no noise, there was no G-forces, there was no stress. So we had to conduct in-flight experiments. So this was very expensive, those flights. And so we asked the pilots, they have the task to pronounce the digits 0 to 9 in various flight conditions. So we asked them to come to the lab so that we can explain what they had to do. I say, no, we don't come. We know what it is. I mean, we are experimented jet fighter pilots, and we know pronouncing digits in isolation 0 to 9. You don't have to explain. Okay, so they refused to come to the lab. So they did the flight, come back to the lab with the recordings, and we listen to the recordings. And it says, so 0, 1, 2, and so on, 8, and 9. They did end before each 9. So I believe this was probably it is probably the most difficult task, this pilot-plane dialogue for jet fighter. To my understanding, it's still not operational in a modern jet fighter. I may be wrong. You'll tell me. And my feeling is that we spent all the years trying to find easier tasks that could be fulfilled with the progress in computer power and computer storage. I think they still plan to have this spoken dialogue for the next generation of the Rafale, but there is still no data for training because it's still classified secret defense. So, as we had both speech recognition and synthesis in the lab, we were one of the very few labs in the world to have both speech recognition and synthesis. So I developed some human-machine spoken dialogue systems in, let's say, normal conditions. So what I did, instead of showing the result on the screen of what was recognized, I asked the computer to pronounce it. So I say like 1, and I was waiting the computer to say 1. To pronounce 1. So we say 1, and instead of that, I heard the computer saying 1, 1, 1, 1, 1, 1. So I was wondering what's going on, and I figured out that it was actually recognizing its own voice. So pronouncing it and recognizing what it was saying. So this is what we call open mic. So to solve the problem, we use what is called closed mic. So we press the button before speaking. So I developed a demo with this. This was for a big exhibition organized by CNRS with the visit of the Minister of Research, Jean-Pierre Chevènement, at that time. So I prepared the demo, and in the demo, I would say the name of a minister, and the system would pronounce the name of his ministry. So I was at the exhibition, a minister came, and so I started the demo, I pressed the button, I said the name of the Prime Minister was Pierre Mauroy at the time. Say Pierre Mauroy, computer say Prime Minister. Good. So then I say Jack Lang. So press the button, say Jack Lang, and computer say Minister of Culture. So then I say Jean-Pierre Chevènement. Nothing happened. So I say again, Jean-Pierre Chevènement, still completely silent. So I was wondering what was going on. And the people, cabinet was a little bit worried. General Director of CNRS was there, also annoyed by this. And the minister told me, don't worry, it's a demo effect, you don't have to worry. And then I figured out that I just forgot to press the button. So press the button, say Jean-Pierre Chevènement, it says Minister of Research. Initially, so we asked systematically the confirmation of the recognition. So he gave a funny dialogue, such as, so you would say go, and computer say, did you say go? You say yes. Computer say, did you say yes? You say yes. Did you say yes? And so on and so forth. And it's even more funny if it makes mistakes. So you say go, and you say, did you say no? You say no, and say, did you say yes? You say no, and you say yes, and then no. And so on. So that's fun. And then we introduce a confidence measure for recognition. Okay, so I don't know if each of you know what this is. It's magnetic tape, and I'm sure that younger people don't know what this is. And actually, this is what was used to distribute the data in what was probably the very first international automatic speech recognition systems evaluation campaign, what is called now shared task. And this was organized by NATO, RSG-10 group, which was led by John Bidle at the time, later on by Roger Moore. And actually, I think this tape, which contains the data, is the one recorded by Roger, because this initial RM are on the box. So this was distributed to the 9 participants, testing 6 different systems, including a human listener. And so I did the testing as well on my system, and the results were good, except for one language, for Dutch. I'm sorry, Dirk. So probably you know that Dutch is a very difficult language, very strange sounds, like 8 is hard. And this was very bad for my system. It didn't recognize very well. So what I did, I took the tape, put it reverse, and do the testing. And for human, it's absolutely impossible to recognize what is being said. But for the computer, it was much, much better. So I got good performances. And it was probably one of the first cases of what is called data augmentation. Okay, then finally, I wrote an article for Le Monde newspaper in France in August 1980. It was for science fiction, so the future it was called a speaking computer. This was the title of the article. And it was accompanied by a nice drawing from a famous graphist named Martin Véron. And it's a brave man who is at night in the fridge looking for some food. And the fridge has a loudspeaker on the top. And the fridge shouts, "Madame, Madame, your husband is still awake." And the spouse from the bedroom, she shouts, "I gave him permission." So I don't know if we reached this level of sophistication, you'll tell us. But so let's see now what came next and where we are now. Thank you.
Thank you, Joseph. Can I ask the panel members to join us here on stage? I can introduce the members of the panel. They're not sitting in the order on your list here, but that's no problem. Shall I go in degree of grayness? At the second chair, there is Roger Moore, which Joseph mentioned as being in charge of RSG10, and I think that's how I met him at some point in life. Then to the left of him is Alex Acero. Then here, closest to me, is Sanjeev Khudanpur. And then there's one person who's not fully gray yet. He's just starting to gray, and I don't know what he's doing in this panel, is Shinji Watanabe. So, okay, that's the people. As Joseph was talking about the very early ages, I put a picture of him in black and white, and the other ones I took from the program, as they are. Next slide. What we're asking the people here is, what was speech research about 50 years ago? That was the original thing. And also, what was it like to be a speech researcher? And I just thought about this myself. Next, please. And then I saw two things. I was thinking about my master's student years working on a Varian 76, a 50-year-old computer. And we were having a problem. We were finding something, and the engineers and math people here will know the Gibbs phenomenon. And we thought we had discovered a new one. But after 3 weeks of painstakingly debugging, we discovered that this computer was making computational mistakes. So there it was, our great science. Well, that was part of science in those days. We had to live with the computers we had. And 10 years later, I was at IBM, being lucky enough to work on one of the biggest computers and having the biggest databases so that we could build state-of-the-art systems. But the only thing there was, we were working on a computer that had called an operating system TSO, which stands for time sharing option, meaning the more you hit the keyboard, the more cycles you got. So during my 1.5 years as postdoc at IBM, I used up quite a few keyboards. It was the only cost they had with me. For the rest, I think I did perform well. But now, that's just for setting the stage. How was it like 50, 40 years ago? Maybe one more slide. Also this I've used at several times before. We are living in this world of Moore's law, in this electronic world of, what did Alex say, billion times, trillion times improvement. But when we look at other things of humanity, also a sector which is big, which has grown tremendously, but from a technical point of view, when we look at airplanes, 50 years ago or today, twice the size of the number of passengers, 50% improvement in fuel efficiency, the range maybe double. So not that much difference over 50 years. It's a totally different world. So that's for me for reflecting on it. And now I actually want to start with our first panel member, Roger Moore. The Roger Moore.
Thanks, Dirk. Thank you very much. Hello, everybody. And thank you, Alex, for inviting me to be here. It's absolutely fantastic to be back in Baden-Baden. So the exam question that we were set, as you heard, was to talk about the past, the present, and the future. And so I was inspired by something which will appear on the screen any moment, I am sure, which is... Thank you. Finally, a Christmas Carol. Because, of course, we're not just talking about the past, present, and future. For entertainment, we're also trying to derive some lessons about how we go about this science in this amazing area that we find ourselves up here at the moment as representatives of the speech community, which is an absolutely wonderful group of individuals who've been doing tremendous work over quite a number of years now. So if we can have the next slide, please. So what I want to do, as you've just heard, I've been in the field for quite a long time. Next slide, please. And I built my first recognizer as a PhD student in 1973. That's the front panel, electronic apparatus for recognizing speech, ears. Already an enthusiast for acronyms, which became a very useful ability when it came to EU projects and beyond. So whilst we're all comparing old computers, I was working on a PDP-8, which had 4K of RAM, and I was the first person in our university to program into the extended memory of 12K. And I had to do everything on there, and the data that was used to store the templates, which in those days is how you did speech recognition. You had to store examples of speech. That was on magnetic tape, which took quite a long time to upload and download, as you can imagine. So that's how far back my credentials go. And I became quite famous in the lab for shouting at this machine because it didn't work very well. And in those days, I mean, we all take for granted now you can just speak normally, as we see on the live transcription. But in those early days, you could only use one word at a time. And so it was very tedious for anybody else who was in the lab hearing me interact. Okay, next slide, please. Next one. So we built the electronics ourselves. Now, this is something I just want to talk about for the present. This is an old study, 2004, but it is very relevant today, I think. So this is some work that we did in the lab looking at how much data was needed to get an acceptable recognition rate for automatic speech recognition. Because in those days, there was massive competition between labs. The people were very interested in bringing word error rates down. And what I was interested in is not so much how we go about doing that, but actually what do we need? What level of performance is appropriate? Where are we heading and when will we get there? And you can see this graph with some real data points of word error rate reducing as a function of numbers of hours of data. And you can see some dotted lines, which are the extrapolation into the future. If we have the next slide, we should see a line come in. So that's human level performance. So humans are not perfect at recognizing speech, as I'm sure we all realize. And then if we go to the next slide, there was always a thought that we needed to be as good as people. And I showed, and some quite separate research, that actually we needed to be about half as good as a person, and it still would be a viable technology for a whole range of applications. But the question was, okay, so when are we going to get to that? And as you can see, the extrapolation puts us way out. So just for your interest, a 2-year-old has heard about 1,000 hours of speech. That's a log scale on the horizontal axis, by the way. Next slide. So a 10-year-old is about 10,000 hours. So a 10-year-old, of course, perfectly well-calibrated speech recognition system. Next slide. 80-year-old, so we're just about getting there. And the next slide. 70 lifetimes worth of speech. Now, I was going around different places at the time giving a presentation using this data, and my message was, we're doing something wrong here. We need to be on a different track. We need to use not a data-driven approach. We need to use something more informed with stronger priors. And the community said, let's just collect the data. And it's worked. So it turned out that this was rather than it was supposed to be a warning, it turned out to be a prediction, and quite an accurate prediction at that. These days, modern systems are using this phenomenal amount of data. And I still like to stand up and question whether this is the most efficient way of building this kind of technology. And not only is it very effective in speech recognition, but in speech synthesis. And as Alex hinted, we've now got open tools available to anybody, including bad players. And we're seeing the possibility of, so speech recognition is now what I like to call deep snooping. Can listen to what we're saying even when we don't want it to, and speech synthesis become deep fake, or as Alex said, we can now recreate anybody and get them to say anything we like. And I think a lot of us did not anticipate there would be these negative consequences of all the work that we're doing. The next slide. Thank you. So this is just the last one. So this is my future. I'm personally very interested, always been interested in real-time interaction with speech-enabled systems. And it's become very apparent to me that we have the most phenomenal spoken language technology, and yet we don't really understand a lot of fundamental principles of how to integrate that properly with a non-living artifact or agent with which we're going to interact. And this pyramid is just to show that, in my mind, there's a whole bunch of things that we need to understand in order to put spoken language in its proper place in interaction. We take it for granted that between living systems, between human beings, we understand what's going on. But when we put it in a machine, we are placing it in a very different situation. People get confused. They don't know what this thing is. And even the thing itself may not realize it's being spoken to or why. And so here's just a list of potential, thank you, topics, extensive range of things we still don't fully understand and need to get to speech-based interaction with non-living artifacts. Thank you.
Okay, thank you, Roger. Let's move on to Alex.
So I met Alex Weibel in 1987 as a young PhD student at Carnegie Mellon. And I was just wandering in the basement of Wing Hall, and someone introduced me to him and said, Alex, this is a new PhD student, Alex Acero. And he looks at me and says, oh, another Alex. It turns out that it wasn't, at first I was surprised, but it wasn't just the two of us. We had another Alex Rudnicki and Alex Hopman. 4 Alexes, that's the largest concentration of Alexes I've ever seen in my life. And they were all working on speech. So I figured maybe this is not a bad thing. So I started studying speech. And one day, of course, we were not just every weekend spending the time in the lab working or programming. I would go to a graduate student party. And they were introducing me to people. So Alex, where are you studying? So, well, I'm preparing for a final for my class in artificial intelligence. And looks at me and says, I am so sorry to hear that you're working on that. How things have changed in the last 40 years. Now everyone is doing something about AI. So that was my experience at Carnegie Mellon, which I'm very appreciative. I learned a lot. And I also met one other person there, XD Huang, who's sitting there, who later hired me into Microsoft Research. And I spent 20 years there doing research, managing researchers, and it was like a fun time. I just wanted to mention one little thing that was a big inflection point, at least for me, maybe even for the field, which is in 2009, one of the researchers in my field, in my group, Li Den, came and tells me, well, I think there is this paper that this professor at the University of Toronto, Jeff Hinton, has published on deep learning that maybe we should try to apply for speech, because he's been getting great results in image. And at first I said, well, so he suggested that we invited him. By the way, you all know Jeff Hinton is very famous now with his Nobel Prize. Back then, he was still very famous, but not as famous, obviously. So we invited him and spent a few weeks. And he brought up a MATLAB program that did the MNIST, handwritten digit recognition, using these deep learning techniques. And then the team applied it then to speech recognition, got so good of a result that at first I thought, no, there must be something wrong. That's too good to be true. So I asked another member of the team to go and validate it. No, it's good. We got a great reduction in error rate. So I put everyone there. And we started submitting some papers, published a couple of papers in 2010. And they were called DBN, because that's what Jeff Hinton liked about deep belief networks. And when we published the third paper, one of the anonymous reviewers told us, I suggest that you don't use DBN because it's already taken. It's dynamic Bayesian networks in our field. Why don't you pick some other name? How about deep neural networks? So thanks to this anonymous reviewer, we submitted this paper with the term deep neural networks. And if you look at the papers in ICASP and many other conferences, the number of papers with the term deep neural network exploded after 2010, 2011. So we're very happy that we played a little role in the jump-starting the deep learning revolution in speech and later in image and others. It turns out that a lot of what was there was a lot of the technology that our own Alex Weibel had done with TDNNs, with some modifications and a lot more computer power and a lot more data. So that was like a fun time. After a few years, Apple introduced Siri, and I thought, well, I've always been interested in making not just algorithmic improvements, but making a difference in the real world. So I went to Apple to build that. And since the title of this workshop is about technology for the benefit of humanity, I wanted to show you a system that we deployed 10 years ago, exactly. Let's see. I don't think that's the one. And in the meantime, I will tell you that this was a technology that we developed for accessibility, to make people that have problems with like motor skill impairments to navigate computers. Like computers was like a godsend for all of us, but not if you can see the context of the screen or if you cannot really type. And it would be great if you can see it, because that's one of the areas that I've really been very interested in. That's how I got into the field of speech recognition and speech synthesis to start with, because I was very interested in what can we do with this technology to make a difference in the lives of people. This is something that we shipped 10 years ago, and we are so pleased that so many people are using it, and they still send us emails saying how thankful they are. We built screen readers for people that couldn't read the screen, visual impairments. We built something we call personal voice, so that users that lose their ability to speak due to throat cancer or Parkinson or other conditions, they can record voice bank their audio and build a system that speaks in their own voice, not somebody else's voice, and many, many more things. So it's very rewarding to have worked in a field where we can make improvements in the lives of people. And it's very exciting that we have worked in AI, actual intelligence, not just artificial. Thank you.
Thank you, Alex. The next person on my left here is Sanjeev. Many people know him. He's continuing the organization of those Johns Hopkins summer workshops. And I had the pleasure of being at one. That's also when we got to know each other better. And actually, it reminds me of something that Alex said in his talk. It was 2010, the dawning age of those DNNs. And on the team I was with someone else from Microsoft, there was also Fei Sha, who tried to get a image processing board to work. Well, that's what he spent the whole workshop on, and it didn't work. And we didn't get...
And he burned it.
I didn't know, but he ended up. But those were the early days of DNNs. It didn't just work like that. And when you look at NVIDIA today, well, things have changed quite a bit. But I give the work to Sanjeev.
Thank you, Dirk. So I will tell you two stories. But before I do that, let me very briefly say, who I am, what I do. So I'm Sanjeev Khudanpur. I came to this field from a very different area. I used to be an information theorist. I used to prove theorems for my PhD thesis. And, theoreticians always have a chip on their shoulder because they think they do things properly. But then I got tired of that and decided I want to do something practical. And another luminary in our field, like Alex, his name is Jelinek, he recruited me to come to Hopkins, and I went there. And just in case people don't understand, Hopkins has a very large and excellent speech and language group. And to quote one of Alex's colleagues, Rich Stern, if there's any lab in the world which can challenge CMU's hegemony in language technology, it's Hopkins. So in some sense, we are the enemy. But the stories I'm going to tell you is going to be just the opposite. These are stories of collaboration. So in fact, I was thinking about it. I met Alex almost exactly 30 years to the date. 1996, June. We had one of these summer workshops. So to talk about the spirit of cooperation like you're saying, one of the things we do is every summer we get about 50, 60 people to come and stay at Hopkins, work together for 2 months. And we've made a lot of great breakthroughs through these workshops over the years. And Alex was at the one in 96. And he and others in the room will know these names, Mari Ostendorf and Liz, who's now at University of Washington, Liz Schreiberg, who's in Silicon Valley. All these people worked together for 2 months. Can you imagine getting 4 professors to give up everything else they're doing? And actually, it was more like 20 professors to give up what they're doing and come to one place and work together. That's what we did. And we made some really great breakthroughs. So one of the things I learned about, by the way, at that time, since I had just come into the field, I didn't know anybody. So everybody was just another researcher to me. So there were these big names and Herman Nye and Alex Weibel, and I was like, yeah, whatever. But that actually was very helpful because I was able to speak to them freely and they spoke to me freely, and we really got going very well. So one of the things Alex was doing at the time, which was very different from what the rest of the field was doing, was working on multilingual speech recognition. Just to give you an idea, that summer, we were working on English because that's the one where we had data. That's the one the US government wanted to fund. And another team was working on Spanish. Is Ronnie in the room today already? He was there yesterday. So Ronnie Rosenfeld, another colleague of ours from CMU who's here, he was working on the team that worked on Spanish. And believe it or not, the error rate on Spanish at that time was 85%. That means 1 out of 6 words were right. By the way, if you want to get 1 out of the 6 words I'm saying right, you just have to recognize the, of, and, be, and you're done. So that's all the thing was doing. That's how bad it was. And but we were still focused on English. And Alex had a brilliant student, Tanya Schulz, who's now a professor in Bremen, and they put together this data set called Global Phone, and it was something just to think that you're going to work on 10, 15, I think it started with about a dozen languages or so. You're going to work on all 12 of them all at the same time. It was kind of different, and people were really thinking, Alex and Tanya and others about, well, should we really have a different model for every language? Aren't the acoustics of all the languages the same? Shouldn't they be able to, somehow work together so that if I don't have a lot of Thai or Korean, but I happen to have a lot of other languages, maybe I can bootstrap from them. So, and then in 99, we actually had a summer workshop, one of those, 20 people coming together to work on multilingual speech recognition. So that was my first experience with Alex intellectually. But by the way, I'll tell you another funny story, which is intellectually, it makes me look like a fool now. When I first joined Hopkins, Jelinek wasn't a believer of neural nets. And he said, Sanjeev, these people are making a lot of noise about this thing. Why don't you go take a look? So I spent 4 months as a junior, person in the lab, read up papers, implemented a few things, and then wrote a report. By the way, before coming here, I was looking for the report. I can't find it because we had a computer crash and I lost a bunch of things. But my report basically said, great idea in theory. There are these theorems about how these are universal approximators and this and that. But I've just looked at how much we need to do and this and that. And by the way, the amount of data we need, we'll never get it. And if you have a little bit of data, these things are so horrible to optimize, they will never work. Recommendation, don't bother. We'll continue with them. No, because other methods were established in the field at the time. We're using Gaussian mixtures and hidden Markov models. And so that's the one I pursued. But that's all right, that was good. And so this was 30 years ago. 15 years ago, this paper that Alex mentioned, that one came out in 2011. Microsoft paper saying, hey, speech recognition error rates cut down by some 30-40% just by this one change in the model. Replace that acoustic model with Gaussian mixtures and this and that with the DBN, but I think it was called deep neural network. I know Hinton called it DBNs, but the paper called it DNNs already. And everybody in the world took notice. And around that time, I had hired away a colleague from Microsoft called Dan Povey. He had just come to Hopkins. And Dan said, this is a real thing, we got to do it. And we had started an open source project at that time called Kaldi. So we picked up on it. And that's the second occasion when I had good and great interactions with Alex. There was a program the US government set up called Babel. It was set up by this agency called IARPA, the Intelligence Advanced Research Projects something, not agency, it was some activity. And they were like DARPA, they were funding blue sky stuff, and they had a language program where the program manager said, I want you to work on 25 languages, not just one or two. So it was like one of Alex's 30-year-old ideas being finally brought to fruit by the US government saying we'll work on all 25 of them at the same time. So Alex approached me and said, hey, Sanjeev, let's put together a proposal. So we did. We won the proposal. And actually around the time when we got the award is when I managed to hire Dan Povey. But, if you're a research faculty in a university in the US, you need money. I was like, Alex, can we tweak the budget? Can I get some more money? And everyone's like, no, Alex is a hard negotiator. You're not getting anything out of him. No, people had warned me. They said, he's a tough cookie. Be careful who you work with. But it was the opposite. I was like, you know what? I think you have a good idea here. Dan's a good guy. I have this company, Mobile Technologies. This is one, by the way, that had Jibigo, I think, right? Mobile Technology was part of our team, and they were going to do some, implementation, productization stuff at the end. He said, there's nothing for them to do in the first year. I'll give you their money just for the first year, though. After that, you're on your own. You're going to figure it out. But that 1 year was enough to establish things, and we got going. And in that project, we did fabulous things. The original goal in that project, if you remember Roger Moore's slides, was they were going to give us 100 hours of data in some of the languages in the first year, and 80 hours in the second year, 60 hours in the third year. They were going to keep reducing it, right? And we were so successful with our techniques in the first couple of years that they actually went down to half an hour by the time we got to the fourth year. So it was really an amazing program. And we saw a lot of the things we care about come together. And that's the one where we had a lot of good, friendly competition. So Alex, of course, had his Janus system, and we were building stuff. And by the way, these IARPA, DARPA programs, they're a little bit of a Formula One racing type of thing. You each build your things, and then you compete, and you see who does well. So within our team, we had two things going on. Our group was producing the Kaldi-related stuff. We were collaborating all the time, because I still remember, I think, Marcus, was it you who worked on the pitch tracker? There was somebody in Alex's lab who built an excellent pitch tracker that we used, and we had stuff that Florian used. So it was fabulous collaboration. And I still remember that as some of the best times we had together in my career. And meaning just of all things, not just Alex's collaboration. So it was a great time. We built good stuff. And at the end of the day, these technologies now really work in all these languages. And if you think about the theme, if you're building technology for humanity, what's more important than supporting all languages, right? So this is one of Alex's legacies to our field. Let me stop there.
Thank you, Sanjeev. Now, our youngest member, Shinji, who's will not look back 50 years, but maybe 50 years into the future.
So first, apologize that I'm not senior enough to talk about 40, 50 years ago. So instead, I try to kind of speak about what we are doing and what kind of perspective we should think about it as a community. Please go to the next slide. So before moving to that, I just want to kind of introduce the Language Technology Institute, Carnegie Mellon, because as Farnham and Alex mentioned, we are actually celebrating 40th the 40 years of our department. And our department is actually purely focusing on the language technologies. And we have actually the over 30 core faculties, including Alex and me. Please go to the next. Maybe we can go to the next one. So in CMU speech, the people, we actually are really focusing on community contributions. And our group and the colleagues in our CMU is working on a lot of kind of challenge activity, open source activities, and benchmarking to try to contribute to the community. And of course, not only ours, we also have often collaboration with many universities, including Sanjeev is actually one of my the strong collaborator to working with. Please go to the next slide and the next slide. And one of the challenge activities that we have been kind of organizing is called the CHIME challenge, and which is regarded as one of the successful speech and the enhancement the challenge. And actually, this is one of the collaboration with Alex Group. We organized one challenge called multimodal context-aware recognition, MCORREC. And this challenge finished successfully, and a lot of kind of participants and a lot of technologies happened there. And as you may see, the kind of a major kind of a problem is to understand the speech human communication from the multimodal information, like this kind of the photo. By the way, this kind of photo, we usually kind of make the face blur to kind of hide the privacy, but everyone here probably recognize the center of the people who is. So this is actually great collaboration. We have a great collaboration not only for the CMU within CMU. We also have a collaboration with the Sheffield. We also have a collaboration with JTU to kind of conducting this kind of challenges. Please go to the next one. And the next, recent kind of work we have been working is to build foundation models. Please go to the next slide. So actually, our group is developing the speech foundation model by using academic the computer, and we try to compete with the other kind of the big industries, which kind of creating a very kind of strong models, but we try to compete with them. For example, this slide is automatic speech recognition leaderboard, and as you see, our kind of system is slightly better comparable or outperform OpenAI's Whisper. And please go to the next slide. I often using this kind of a cartoon. Do you know which one is CMU and which one is OpenAI? Please go to the next slide. Yes. Of course, we are not only competing, we are also collaborating to kind of activate the community. Please go to the next slide. Of course, there are a lot of actually issues in the industry. They cannot release the data. They cannot make the kind of reproducibility to the lower priority. Instead, we CMU and our colleagues are actually try to kind of competing with them, try to creating a similar performance, but all kind of reproducible open source, so that we are trying to promoting open source science. And I'm sure this is one of the important keyword that we should push to our community healthy. Please go to the next slide. And this is actually one of my kind of perspective, which is actually related to the CHIME challenge that I mentioned before. So from now on, I think we are moving more to kind of understanding the conversation, and where we actually have to collect all kind of speech, human language technology, which is actually human easily can do, but still computer is not easy to do. So this is probably the most important next phase we have to work on. So this is my slide. Thank you so much.
Thank you all. I think our time is pretty much up, but we have a birthday boy here. So I want to give him the word. As he said, he also has one funny remark about some very old things.
So, I mean, wonderful talks. And of course, I had wanted, and you hoped, and you certainly all delivered, including Joseph. Where's Joseph? Oh. All the funny things of the beginning, and then the great things that are still unsolved. And just one little story I wanted to share with the funny things is when I joined Raj Reddy's laboratory as a graduate student in 1978, the computing equipment we had was atrocious in comparison today. And, all of your smartwatches and telephones have a thing called an A to D converter, which converts the speech into digital numbers that the machine can work on. Well, these weren't on chips on iPhones and things. You had to buy a rack for A to D converter. It cost $40,000 and was half a room worth of electronics. It's a monster of a thing like that. And this is where we sort of recorded speech and converted into digital things and so on. So we had the signal processing guy, Yegnan Rayanan, a professor from India, who was an expert in signal processing. He was in our laboratory, and he told me one day, he says, Alex, you should be grateful that we have this amazing A to D converter. I said, oh yeah? So he says, well, some professor in America wrote me a letter, and well, for those of you who are not technical in the room, 1 second of speech is converted into 16,000 numbers that the computer can understand, right? So if you have an hour of speech, you do the math. But 1 second of speech is 16,000 numbers. And this professor in America wrote us a letter and said, could you please print out those numbers? Because we want to do signal processing research using those speech numbers. And I said, well, but if we print them out, what do you do with a printout of 16,000 numbers for 1 second of speech? He said, I'll have my graduate students type them in. So we were lucky to have great machines at Carnegie Mellon.
Okay, I will please thank the panel, thank Alex for his notes. Thank you all.